Hello, my name is Professor Robbie Pott. I'm a lecturer at the Department of Process Engineering at Stellenbosch University. The Department of Process Engineering at Stellenbosch University is the home of the degrees in chemical engineering that Stellenbosch University offers. So we offer both undergraduate and postgraduate degrees in chemical engineering. So a question we often get asked is, what is chemical engineering? Well, chemical engineering relates to the development or the conversion of raw materials or low-value materials into high-value products. So in this instance, at the bottom, we see an oil rig extracting either oil or natural gas from the seafloor. Chemical engineers have then developed a process which converts that crude oil into petrol and diesel and jet fuel and other interesting products. Another interesting example is the conversion or the extraction and purification of materials from ores into pure components. So you can see some gold that's extracted, and this is obviously an important part of South Africa's economy. But other materials that we extract from the Earth's crust include those which we build our computers with, that we build our buildings with, and so forth. And chemical engineers are the ones who design and run those processes. So what's the difference between a chemist and a chemical engineer? Well, a chemist is concerned primarily with the fundamentals of how reactions occur. They perform experiments at small scale in a laboratory, whereas a chemical engineer uses the techniques and the technologies that chemists have developed to create large-scale processes, to do those conversions at large scale to produce valuable materials that are useful for society. So a chemical engineer's tools include both the chemistry that the chemists use, but more primarily we use mathematics and modeling and process design and optimization to create economically viable and sustainable processes. So how do we train a chemical engineer? Well, at Stellenbosch University, we have a 4-year degree that's EXO accredited, that is the Engineering Council of South Africa. So students who graduate with a degree from us can go and work in any Washington Accord signatory country. Those include Australia, New Zealand, America, the UK, Europe, and many other countries. So our graduates are in high demand across the world, and obviously in South Africa and across Africa as well. Our first year is a common first year between all the engineering undergraduates. So you will be studying with the civil engineers, the mechanical engineers, and so forth, all together in the first year. And you'll see that the 4 years are divided into different types of courses. So in the first 2 years, we focus on mathematical sciences and natural sciences to give you a strong foundation. In years 3 and 4, we move more into engineering sciences and applied sciences, taking those understandings and skills that you learned in the first years and applying them to real-world problems that you can design actual solutions to. You'll also see that there are some complementary studies, things like communication and ethics, so that you can work as an ethical and a proper engineer in the world. And combining those skills will then allow you to develop, at the bottom right-hand corner, you'll see there's an example, for instance, a wastewater treatment facility that takes in waste and converts it to produce pure water and valuable bioenergy. So the Department of Process Engineering at Stellenbosch University has some excellent facilities. We have good undergraduate teaching facilities available to accommodate large classes. We've got state-of-the-art laboratories where cutting-edge research happens. And unique amongst chemical engineering departments in South Africa is we have a large pilot-scale facility. So we have equipment that is comparable to industrial scale that you can work with and you can look at and understand at a hands-on level. You'll be working with alongside researchers who are the top in their field in the world, and you'll be interacting with postgraduates who are learning how to do these things at a very high level. So where do chemical engineers go and work? Well, there's some traditional areas that chemical engineers are often employed in, things like biotechnology, where, for instance, we can make bioethanol from waste materials. The food and beverage industry, so making beer and wine and your favorite chocolate and so forth. Water purification, for instance, is very important in South Africa. So when the city of Cape Town was having a water emergency, it was chemical engineers, amongst others, who were involved with designing and building those desalination plants that were so quickly put up to provide potable water for everybody. The pharmaceutical industry also employs many chemical engineers, and chemical engineers will be involved very heavily with the development of the processes that produce the vaccines, for instance, for COVID. So these are the kinds of places that chemical engineers are traditionally employed in. However, our graduates find employment in a variety of other places as well. The kind of skills and techniques that we learn in chemical engineering make us very good at problem solving and analysis. And so those attributes make us sought after in industries such as data science, which is a growing field, financial services, management consultancy, or research and development, where you are more hands-on in a laboratory. Now, a question that we should ask ourselves is, where is chemical engineering going in the future, and how can we make the world a better place? Now, the skills and the problem solving that chemical engineering instills in a graduate allow us to drive sustainability, industrial development and innovation, and social welfare. On the sustainability front, we were very involved with the development of the technologies that allowed us to grow the economy on the basis of fossil fuels. But we understand that those things cannot continue into the future, and so chemical engineers are also involved with the development of new renewable energy-based fuels, like in the example here, we have corn that gets converted to bioethanol, which we can then use in our normal internal combustion engines. Another example is, traditionally we extract minerals from the Earth's surface, but of course that is also a finite resource. Another area where we could be extracting materials is from waste. Society produces large amounts of electronic waste which go into landfill. Chemical engineers can design and do design the processes to extract the valuable materials from those waste materials. And in our department, we have cutting-edge research on exactly that, extracting gold, platinum group metals, rare earth metals, and so forth from electronic wastes. Chemical engineers can be at the cutting edge of innovation in a variety of areas. For instance, in our department, one professor has developed a process to produce protein in the form of fly maggots, which take waste materials and convert it into high-grade protein, which we can then feed to, for instance, chickens. This then reduces our reliance on unsustainable sources and also integrates waste materials into the food source, the food cycle, so that we are a better, greener society. We develop new renewable energy sources and energy storage materials, green chemicals, and novel materials such as biodegradable plastics. And increasingly, we're using data science, artificial intelligence, and neural networks to understand and optimize these processes. Chemical engineers are very concerned with social welfare and how to improve society. We use our skills and our problem-solving ability to address such critical problems as food security, access to potable water. For instance, in our department, we have a professor who's developed a membrane-based water purification technology that can be used in rural areas where there's no access to electricity or any other materials, so that we can roll out potable water to all people of South Africa. We're also involved with energy security, renewable energy, and making sure that the environmental impacts of new and old processes are reduced, minimized, and eliminated. We have several research areas for when you complete your undergraduate and are interested in doing a postgraduate degree in, for instance, bioresource engineering, which is my own field, where we look at using organisms to produce, for instance, biohydrogen. We have extractive metallurgy as a strong research thrust, where we examine how to better extract the materials that we need to produce interesting technologies. We have a separations technology research group, which uses the fundamental properties of materials to separate and purify. We have waste valorization, which I've mentioned already. We have water technologies, where we purify and increase the access of potable water. And increasingly, we have machine learning, which cuts across all of these research areas to use artificial intelligence and neural networks to make interesting insights into how we can improve all of this. If you are interested in learning more about chemical engineering, or perhaps applying to study chemical engineering at Stellenbosch University, please feel free to drop us an email or give us a call. You're also welcome to stop by our website, where you will also find the application forms and all the information that you need. There are some specific details about application which you may need to look at, and the Dean's presentation will have some information on that. We would look forward to welcoming you to the department and giving you the skills so that you can thrive and that our society can thrive. Thank you.